Hello, Yetta. Now, in order to revise for your topic test, you have been set this piece of revision. So it's actually a homework test, but we've set it for revision because it includes everything that you will need. So there are two sides to it. Now, what I wanted to do is actually go through each of the questions for you. So hopefully it will help you for the things that you are struggling with, and it also means you can check your answers and you're working out as well. So I am going to go through each question. So question 1 is this, and it's all to do with perimeter. So we should know perimeter is just the distance around the outside. Right. So for part A, it's just a rectangle, so perimeter is equal to 2 plus 6 plus 2 plus 6. So the perimeter is 2 plus 6, 8, 10, 16 centimetres. Remember, perimeter is just a length, so units just centimetres. Part B, again very similar. 3 plus 10. Now this is a rectangle, so that must also be 10 metres. That must also be 3 metres. Don't forget those two sides. Plus another 3 plus another 10. So your perimeter is 26 metres. Part C, perimeter 5 plus 4 plus 9, so your perimeter is 18 metres. And last one, perimeter is 120 millimetres plus 50 millimetres plus 80 millimetres, so the perimeter is 250 millimetres. Okay, so that should have been a fairly straightforward first question. Question 2 was this one here. So all to do with circumference and, well, circumference of circles. Now, notice we're asked to give it to one decimal place. We're not given a diagram, so you can draw one if that is going to help you. Right. So we're told that the radius is 6 centimetres and we need the circumference. Well, we should know the circumference is pi times by the diameter. Well, if I know my radius, but I need my diameter, I know my diameter, I just need to double my radius, so that's 12 centimetres. So my circumference is pi times 12. Use your calculator. Pi times 12. 12 pi, press S to D to one decimal place, so that's, so C, the circumference is 37.699 and so on. To one decimal place, 9 rounds up, so the circumference is 37.7 centimetres. And that's your final answer. Question 3 then. Looking at area of polygons, straightforward polygons. Now, when you are doing any question that requires a formula, just like I did in the previous question, make sure you state your formula. So for question 3a, the rectangle area is length times by width. So the area is 4.3 times by 2.4. This is a calculator question, so you can just stick that in the calculator, give it to one decimal place, read the question. So area is 10 10.32, or to one decimal place, area is 10.3 centimetres squared. All lengths are in centimetres. Okay. Now, part B is a triangle. It's actually a right angle triangle. Part B, so my area is base times height divided by 2. That's my base, that's my height. So area is 10.3 times by 6.6 divided by 2. Which, a couple of different ways to put this in your calculator, but I just do 10.3 times 6.6 equals, divided by 2, is 33.99. Now this is where it's going to be a little bit interesting because I want it to one decimal place. 9 rounds up, so area is 34. Now because I want it to one decimal place, I have to put that 0.0 on. Again, centimetres squared. Now it is possible in an exam, if you just put 34 centimetres squared without the 0.0, you would get it marked, or you would lose the last mark. Part C, this one here is a parallelogram, and we should know the area is base times height, or more precisely and more mathematically accurately, it's base times by perpendicular height. In other words, it's perpendicular to the base at right angles to the base, so that is that distance there, not the 9.5, and that's a really common mistake that people make. Okay, so the area is base, which is 15.3, times by the height, which is 9.1. 15.3 times 9.1 is 139.23, which to one decimal place is 139.2 centimetres squared. I'll just pause there for a second. Okay, part D is a trapezium. Now there's a couple of different ways that you may have seen the equation for the area of a trapezium. I say it is A plus B divided by 2 and then times by the height. Now again, that is the perpendicular height. Now A and B are your parallel sides, so if we look at the diagram, A and B would be there. You could have them the other way around, it doesn't matter. So your area is 2.8 plus 10.2. I'm going to half that and then times it by the height, which is 3.1. So using my calculator, 2.8 plus 10.2 equals, divide that by 2 and then times by 3.1. And that gives you 20.15, or to one decimal place, the area is 20.2 centimetres squared. And lastly, the triangle. Again, we need to be careful. Area is base times by perpendicular height divided by 2. And your perpendicular height here is 17, not the slanted side, which is 18.5. So area, base is 20.4, perpendicular height is 17, and then divide that by 2. 20.4 times 17 divided by 2, which gives you 173.4 centimetres squared. Exactly, so that doesn't need bounding. And I'll just pause there because that's the end of question 3. Okay, question 4. We're asked, well, we're told that this is a sector, part of a circle. We're asked to find the perimeter and the area of the sector. Now, I'm not going to explain where the formulas come from that I'm about to use. The reason for that is because I've explained them in a video previously, so I'd just be repeating myself. So if you're not sure about where the formulas that I'm about to use come from, look back at that video on the lesson on class charts. Right, so I'm going to do the perimeter first. Right. So in other words, we need that arc length plus that length plus that length. So the arc length is theta divided by 360 multiplied by pi multiplied by d. The angle, so that's an angle there, which is 120 degrees. So 120 divided by 360 multiplied by pi multiplied by the diameter. Well, in this I'm told the radius is 5 centimetres, so therefore the diameter is 10 centimetres. So I'm going to multiply it by 10. Now I can just stick it in my calculator. 120 over 360 times pi times 10 gives you 10.4719 and so on. So that's 10.4719 and so on. And so we've now worked out that this length here is 10.4719 and so on. So I now need to add on 5 centimetres there and the 5 centimetres there. So therefore the perimeter is 10.4719 and so on, plus 5 plus 5. So the perimeter is 20.4719, so on. We're asked to give it to 1 decimal place, so the perimeter is 20.5 centimetres. Now the area we need to use the formula area of a sector is theta, or the angle, divided by 360 times by pi times by r squared, where r is the radius. So the area is going to be 120, because that was our angle, divided by 360 times pi times by our radius was 5 centimetres. times by 5 squared. Again, stick in the calculator. 120 over 360 times by times 5 squared gives you 25 over 3 pi, which is 26.1799, so on, which to one decimal place again is 26.2 centimetres squared. Remember, it's an area, so our units are squared. Again, I'll pause there for a minute. Okay, the next question is basically asking you to find the surface area and the volume of a cuboid. Right. Now, I'm going to do surface area first. Now, we should know from the lessons that we've done, and actually from year 7, 8 and 9, that for a cuboid, the faces come in pairs. And what I mean by that is, if I show you what I mean by highlighting, that, for instance, this side here is exactly the same as the one at the back. The top is going to be exactly the same area as the bottom. So that bit there is going to be exactly the same as the bit at the bottom that you can't see. And then this bit here, the right hand side, is going to be identical in area to the left hand side here that you can't see. So I'm just going to label these to make things easier, A, B and C. So if we look at area A, this bit, that's going to have an area of 6 times 8, which is 48 centimetres squared. If we look at B, that's going to have an area of 8, because it's the same length as this, times by 10, because it's the same length as this, which is 80 centimetres squared. And then C is going to have an area of 6, because it's the same length as that side, multiplied by 10. So we've actually worked out 3 faces, but because they come in pairs, we're going to add them up and then double our answer. So if I add that up, I get 60 plus 80 is 140, plus 48 is 188 centimetres squared. So therefore the total surface area is 188 centimetres squared multiplied by 2, which gives me 376 centimetres squared. So that's my total surface area. Volume is actually easier. The volume of a cuboid, we can use the formula length times width times height. So the volume is, length is 8, width is 10, height is 6. 6 is 48, times by 10 is 480. But again, you could have used a calculator. Now, be really careful, your units. It is a volume, so therefore it's cubed. Again, I'll just pause. Okay, question 6, which was the last question on the skills part, is this one. Now, this is one of the more difficult questions on the revision task that you were given. Now, an important thing to note, I've given you two formulas in the question. I've given you the volume of a cone and a volume of a sphere. Now, the reason for that is because in an exam, you are given those formulas. You are not, however, given the volume of a cylinder. Okay. So, if we're trying to find the volume of the cylinder, well, a cylinder is just a type of prism, which in other words means that the cross-section here, in other words the circle, is the same throughout. So that means I could work out the area of that circle, the cross-section, and then multiply it by the length. So the way that I set this out is I say, well, the area of the cross-section is, well, it's a circle, so it's going to be pi times the radius squared. So its area is pi, the radius is 3 times 3 squared. So my area is 9 pi. Now, I'm not going to turn that into a decimal yet, because if I do, I'll have rounded too early. So therefore my volume is going to be 9 pi, which was my area of the cross-section, times by my height or length. So I'm going to times by 6. Now 9 pi times 6 9 pi times 6 will give you 54 pi. The question says to 1 decimal place. This is why we didn't round here, because if we did, we would have already rounded, so our answer is already inaccurate. That gives me 169.646 and so on. Now to 1 decimal place, 4 rounds down, so 169.6 centimetres cubed volume. Okay, the second one, which is the cone. So the cone, you are told the formula, so all you need to do is stick the numbers in. However, the volume of a cone uses the area of the base. And the area of the base, or the base, is a circle. So, area of base, and I always split this up again as a circle, so it's pi times the radius squared. Now, let's think about what we're told. All the way along here, in other words, that length there is 90 centimetres. So I am told that the diameter of the circle is 90 centimetres. So that tells me the radius, I'm going to divide by 2, is 45 centimetres. So my area is pi times 45 squared. So if I do pi times 45 squared, I get 2025 pi. And again, I'm going to leave it as that for now. So therefore the volume is a third of the area of the base. Well, we've just worked that bit out. Multiplied by the vertical height. Now the vertical height is the 60, not the 75. Multiply that by 60. So therefore the volume is 1/3 multiplied by 2025 pi multiplied by 60, which is 40,500 pi, or 127,234.5 centimetres squared. Sorry, centimetres cubed. Okay. Now the sphere, again, you are told the formula. And this one is the easiest out of the three, I think, because you do have to just stick the numbers in. So volume is 4/3 multiplied by pi multiplied by the radius cubed. Now we're told the radius is 12, so therefore the volume is 4/3 multiplied by pi multiplied by 12 cubed. So 4/3 multiplied by pi multiplied by 12. Now I can use shift and then that button, and that'll give me cubed, and that gives me a volume of 2,304 pi, which is 7,238.229, or to one decimal place, 7,238.2 centimetres cubed. So that's quite a difficult question. And again, I'll just pause for a second. So we're now moving on to the fluency section. Now these are designed to make you think a little bit more. So the first question, question 7, is this one. So wooden mirror frame is basically made by cutting this triangle out of the rectangle. So what we can do, the area of the shaded bit of wood, so the area of the shaded part is the area of the rectangle subtract the area of the triangle. So if we look at the rectangle, area is length times width. So the area length is 25, width is 20. So that gives me an area of 500 centimetres squared. The triangle area base times by height divided by 2. Now, the triangle's slightly wonky, but if I give you a little hint, if I did that, it would be a lot easier. So that's your base, that's your height. So the area base, which is 14, times height, which is 14, divide that by 2. 14 times 14 should be 196, divide that by 2 is 98. So that's 98 centimetres squared. Now remember, that's not our final answer. So the area of wood is 500 take away 98, which is 402 centimetres squared. And that's our final answer. Okay, the second fluency question asks you to work out the volume and the surface area of a pyramid. And in this case, it's a square-based pyramid, or rectangular-based pyramid, actually. Now again, I've given you this formula because you would be told it in an exam. Let's work out the volume on first, then, seeing as though I've been given this. So the volume is a third times by the area of the base times by the vertical height. Actually, let's work out the area of the base first. Well, the base, although it doesn't quite look like it, actually looks like a parallelogram, but it isn't, it's a rectangle. So that is base times height, or length times width. Base is 6, height is 2, which is 12 centimetres squared. So the volume is a third multiplied by the area of the base, which is 12, multiplied by the vertical height. And it's not obvious to see in the diagram, but it is this dimension here, now this side, length. So 5.7 centimetres. So the volume, 1/3 times 12 times 5.7 is 114 over 5. Give your answer to the nearest whole number. So that is 22.8, which to the nearest whole number is 23 centimetres to volume, so it's cubed. That's a slightly easier part. Now, for the surface area, we need to think a little bit, because it's the area of all of the surfaces put together. So we've got the base, which I'm just going to call A. We've got this part here, so I'll put that in green. That bit there, I'll call that B. Now, if we think about this carefully, because it is a rectangular base pyramid, that triangle and that triangle, although they don't look the same, they are, which means they must have the same area. And now if we look at the front bit here, that bit there, we'll call that C. Now again, although it doesn't look like it, the back part, which I do with a dotted line, is there. Although they don't look the same, they have to be the same, otherwise the sides won't, if we made the net, the sides won't fold up and meet at the point at the top. So if we look at the base, and we call that A, it is a rectangle, so and we already know that that has an area of 12 centimeters squared. If we look at the left hand side, so this green triangle here, we call that B, and as I said, it's a triangle, so it's base times height divided by 2 for its area. So the area is base, which is 2, times by the perpendicular height, which is 6.4, and divide that by 2. So that gives us an area of 6.4. Now, if we think about this and look back at our diagram, we've got a triangle here, so this face is identical to the other green face. So actually, all I'm going to do is I'm going to times my answer by 2, which gives me an area for those two faces of 12.8 centimeters squared. Similarly, for the pink face, or faces, the front and the back, the area is base times height divided by 2 again. The base is 6, the height is 5.8, then I need to divide it by 2. 6 times 5.8 divided by 2 gives us an area of 17.4. Now again, the front and the back are the same, so I need to times it by 2. So the area of those two faces is 34.8 centimeters squared. So therefore the total surface area is equal to 12 plus 12.8 plus 34.8 12 plus 12.8 plus 34.8 gives you 59.6 centimeters squared. To the nearest whole number, that is 60 centimeters squared. So that's how we would find the total surface area of that rectangular pyramid. Okay, so we've got a hemisphere, which is half a sphere, and we need to find the total surface area. Okay, now I should have told you that the surface area of a sphere is 4 times pi times the radius squared. Now we're told our radius is 5. 5 squared is 25, times 4 is 100. 5. And I'm going to leave it as that for now. Now, what that's actually told me is if that was a full sphere, or a ball shape, that would give us a total surface area of 100 pi. But we haven't got a full sphere, we've got half a sphere. So the surface area of a curved surface area of a hemisphere is going to be 100 pi divided by 2, which is 50 pi. So that's given us everything other than the circle at the bottom. And we can work the area of the base, which is pi times the radius squared. Radius is 5, so that's going to give me 25 pi. So our total surface area is equal to 50 pi plus 25 pi, which is 75 pi which is 235.61. So on to one decimal place is 235.6 centimetres squared, because it's an area. And that's it. So, I hope you found those useful. If you can do all of those questions without any problems, then you shouldn't have any worries for your topic test. Thanks for listening.